Welcome back to Calculus. I wanted to take a minute and show you how to use Desmos to compute average rates of change of a function. This will make some of the homework problems a lot easier because you have to do these calculations several times over, and so having a nice bit of software to help us is useful here. Let's take a look. So if you go to our My Open Math page and kind of scroll down just in the middle of that very first block, that sort of welcome block or the intro block here that has all the basic class information, you'll see a link to Desmos right here towards the bottom. Click on that, and that'll open up a new blank Desmos graph. Suppose we wanted to investigate the function, say 1 over x. I can just type in f of x equals 1 over x, and Desmos immediately pops the graph up there. So there's the familiar graph of 1 over x. Suppose I were interested in rates of change of this function, say rates of change near x equal 2. I could compute average rates of change on intervals containing 2 by just giving the interval I'm interested in and then inputting the right formula to Desmos. So, for instance, suppose I'm interested in the average rate of change from x equal 2, so the left-hand endpoint I'll call 2, I'll name that A. My right-hand endpoint I'll name B, and let's suppose the right-hand endpoint is 3. So this means I'm interested in the average rate of change of f from A equal 2 to B equal 3. Well, if you remember our material from the text and lectures, average rates of change are equivalent to slopes of secant lines, and we know the formula for those. Those are given by the difference quotient for f across the interval. So what we would need here to find the slope of the secant line, or the average rate of change, would be that difference quotient. And so you can just enter it like this: f of b minus f of a over b minus a. And Desmos shows us the answer. It's minus 0.1666, about a negative 1/6. So the average rate of change of 1 over x on the interval from 2 to 3 is negative 1/6, negative 0.1667. And if you think about it, if you think about the secant line connecting those 2 points, it would have a shallow negative slope. So negative 1/6 looks about right. We've talked about the fact that instantaneous rates of change, for instance, the instantaneous rate of change at a equal 2, you could approximate by making b very close but not equal to 2. So if b is 2.1, we see an average rate of change of about minus 0.238. And keep making it closer and watch that number change. Now with b equal 2.01, it's minus 0.2487. And as b gets closer and closer, watch those values of m and ask yourself, are they approaching any definite number? And you can kind of see that they appear to be. It looks like we're approaching minus 0.25. I'm getting minus 0.24 and then a whole long string of nines and then some extra change. This is the average on the interval from 2 to 2.1, 2, 3, 4, 5, 6, 7, 8, zeros, and then a 1. So we would estimate that the instantaneous rate of change of f at a equal 2 would be minus 0.25. Desmos makes it really easy to compute those average rates of change and then to use them to estimate an instantaneous rate of change. And I encourage you to use Desmos on your homework problems. It's a great learning tool, and we'll be using it quite a bit in class. That's it for this short video. If you have questions, let me know. Otherwise, I'll see you back here again real soon.